to start out section 5.4, go ahead and do this introduction activity on your own. Pause the video, do it, and then come back and we can check them together. So go ahead and pause the video and do that part. Alright, so let's do this together and check our answers. It says, since 6 times 3 equals 18, 6 and 3 make up a factor pair for 18. Find the other factor pairs for 18, including negative numbers. Alright, so for 18 we know 6 and 3 multiply together to get 18. What else? 2 and 9, 1 and 18. And then it said the negative one. So if we take negative 6, that'd be negative 3 together, make positive 18. Negative 2 and negative 9. And then negative 1 and negative 18. Alright, now it says find the sum of the integers in each factor pair for 18. So we're going to go through and we're going to add each of these together and write down the answers. So the first one, let's see, that's 9, 11, 19, and then negative 9, negative 11, and negative 19. Alright, so that was all for the number 18. Now it says, does 12 have a factor pair with a sum of negative 8? So what numbers together make 12? 3 and 4, 2 and 6, 1 and 12. I think that's it. Alright. Or negative 3 and negative 4, negative 2 and negative 6, negative 1 and negative 12. Do any of those make negative 8? So yes, our answer would be negative 2 and negative 6. What about a sum of negative 9? Do any of these add up to be negative 9? No. So our answer would be no. Now it says, using all the factor pairs of 12, how many sums are possible? Well, let's see, that's 7, 8, 13, negative 7, negative 8, and negative 13. None of those repeated, so we have 6 possible sums. Ooh, how many sums are possible for the factor pairs of negative 12? Well, let's list those out. Well, we have 4 and negative 3, negative 4 and positive 3, 2 and negative 6, 6 and negative 2, 1 and negative 12, and negative 1 and 12. So let's see if any of those repeat. That'd be 1, negative 1, negative 4, 4, negative 11, and positive 11. So none of those repeat, so we'd have 6 again. So the number of factor pairs can give us the number of possible sums. Alright, so that's just a good start for what we're doing in 5.4. We have to think about what numbers multiply to get one number and add to get another. So that's part of what we're doing today. The first thing we're doing is kind of like undistributing. Alright, we're going to take something that's common between each term and bring it out to the front. Like, we're going to simplify. So first here we have like terms. We can combine those. So we get 4x squared plus 8 when those are combined. And then do we have something common between the two terms? Well, 4 goes into 4x squared, right? And 4 also goes into 8. So what we can do is bring it out to the front. And in order to do that, you divide each term by 4. So our answer will be 4 times, these two cancel, so we're left with x squared, and these can reduce to 2, so plus 2. So our answer would be 4 times x squared plus 2. On these, you can always check yourself by distributing that 4 back in. Would it come back to equal the original simplified expression? And the answer, of course, is yes. All right, so the next one, do we have any like terms to combine to start off with? No. What's common between 9n squared and negative 24n? Well, there's a common n that we can definitely bring out to the front. Let me write this out so I don't write all over the problem. So we can bring an n out. What else goes into 9 and negative 24? 3. So we are going to divide each term by 3n, which leaves us with 3n, and then, let's see, 9 divided by 3 is 3, and then n squared is like n times n. So we can cancel the n on the bottom with one of them on top. So we're left with 3n minus, reduce over here, 24 divided by 3 is 8, and then the n's cancel, so we get just a minus 8. So that would be our answer, 3n times 3n minus 8. All right, let's do the last one. What is common between all of these terms? A 3. So we are going to bring a 3 out to the front. And that means we have to divide everything, each term by 3. So our answer will be 3 times, see, these reduce to 3x squared. Those 3 cancels and we just have a plus x. And then these cancel, reduce to negative 6. So we have 3 times 3x squared plus x minus 6. And like I said, you can redistribute it and check that it'll come back to here, which it will. So that is called finding the greatest common factor. So these numbers here in front, those are the greatest common factor. What's the biggest thing that all of them have in common? And we bring those out. So we factored by bringing the greatest common factor to the front. Now this, the first few problems on your homework are like this, the first 6. And then after that, we're actually going to use this sometimes in our other problems. So let's go to the back and look at those. All right. These are factoring trinomials. A trinomial has 3 terms, like our standard form here, ax squared plus bx plus c. And we're going to factor it. It's kind of like unfoiling. When you FOIL, you have 2 binomials, so things that have 2 terms. You have 2 of those, and then you do first, outside, inside, last. Well, what we're going to do is reverse that, okay? The steps aren't first, outside, inside, last, reversed, but that's basically what we're going to get back to, are those 2 binomials being multiplied together. Our steps are up here. So step 1 is to factor out the greatest common factor, GCF, if possible. So if there's a common 2 in all the terms, bring a 2 out to the front first. The next thing to do is set up our big X. So that's this right here. And to do that, we're going to take A times C and put it in the top triangle. So A times C, whatever those numbers are. And then you take B and put it in the bottom triangle. Now, the side triangles, you fill those in by finding the 2 numbers that multiply to get the top, A times C, and add to get the bottom, B. So these 2 numbers multiply to get A, add to get B. That's step 2. Step 3 is we take these numbers that we found, whatever they are, and put them in fractions where the denominator is A. All right? Once you've done that, you have to reduce if possible, or else it doesn't work. Reduce is so important. All right? Reduce if possible. And then these fractions are actually going to turn into our factors. Okay, so whatever the A is down here, once it's reduced, the denominator will come here and be coefficient, the number on top will be the constant, and then the same thing back here, coefficient and constant. The same pattern happens every time. So let's try it. We're going to try example A first. The first step was to factor out a greatest common factor. So is there something common between all three of these? Yes, there's a common 2. So we need to bring a 2 out to the front. And in order to do that, divide everything by 2. Okay, so we will have 2 times, these cancel, we get x squared. Negative 12 and 2 reduce to be negative 6, so minus 6x. These reduce and get 8. All right. That's step 1. Now step 2 is to set up our big X. So I'm going to do that here. All right. So remember that our greatest common factor, this one, it's just going to hang out in front until the very end. We don't have to do anything with it anymore. It's just going to hang out. Just don't forget about it. It doesn't like to be left out. Don't forget. All right. Now, the A, B, and C are going to come from right here. So we're supposed to have A times C right here. So what is that for us? We've got a 1 in front of the x squared times 8. So that is just 8. All right, and then we need B in the bottom. So that's a negative 6. All right, we're doing good. Now, what numbers multiply to get 8, add to get 6? Honestly, I think the best way to think about this is just take 8 here and list out numbers that multiply to get 8. So like 1 and 8, negative 1, negative 8, 2 and 4, negative 2 and negative 4. Do any of those add to get 6? Well, yeah, or add to get negative 6. Negative 2 and negative 4. So that's what you fill in here, negative 2 and negative 4. Double check yourself. Do those multiply to get 8? Positive 8. Signs are important. Do those multiply to get positive 8? Yes. Do they add to get negative 6? Yes. All right. We're doing good. Step 3, turn these numbers into fractions where the value for A is the denominator. So we will have negative 2 over what was A, 1, and negative 4 over A, which is 1. This is where you reduce if possible. Can we reduce those any? No, we can't. So we're going to move on to the next step. Well, this will be our answer. So y equals, don't forget about the 2. Remember, it doesn't like to be left out. So 2 in front, and then we set up our binomial parentheses. And then we have an x and an x. The number that goes in front of the x is the denominator. So that goes right there. Well, that's just a 1, so we don't really even have to write that. Okay, the number that goes behind the x is from the numerator, so we'll have a minus 2. Same thing from the other side. The 1, well, we don't really need that because it's just a 1, goes in front, and the negative 4 goes behind. So this is your answer. If you foiled these back out and then distributed the 2 into everything, you would come back to this original expression. All right, pause the video if you need to write any of that down. And we will keep going and do some more examples. All right, so let's try example B here. First step, is there anything common that can be brought out to the front from all those? No, there's nothing common between all three, because it has to be between all three. So there's nothing common, so now we go straight to our x, our big X, okay. What is, let's see, this is A, B, and C. So what is A times C? That's 1 times 32, so that's just 32. What's B? 12. And now we need factors of 32 to add to get 12. Let's see, 1 and 32, 2 and 16, 4 and 8. Oh, did you see that? 4 and 8 add to get 12. So we can plug a 4 in here and an 8 in there. Very good. We're doing good. All right, now it's time for our fractions. So our fractions will be each of these numbers with a as the denominator. So that's going to be 1. So we'll have 4 over 1 and 8 over 1. Next step is to reduce. Can we reduce? No, there's nothing to reduce. So now we just write out our factors. We didn't have a greatest common factor this time, so nothing goes in front of the parentheses. What goes, let's see, a 1 goes here, don't need it. That's a positive 4, so we write plus 4. And then the 1 goes right there, and then a positive 8, so we write plus 8. So there are our factors for x squared plus 12x plus 32. If you see here, the last term when you would FOIL would be 4 times 8, which gives us 32. And the middle terms, when you'd multiply, the outside would be 8x plus 4x, which gives us 12x. So that's where we get that these numbers multiply to get 32, add to get 12. Pause it if you need to. If not, let's keep going. All right, this one is their greatest common factor to factor out at the very beginning. No, there's nothing common between all three. So set up your x. All right, we have A, B, and C. So first we need A times C, which is 12 up top. B is by itself on bottom. What factors of 12 add to get 7? 1 and 12, 2 and 6, 3 and 4. There it is, 3 and 4. Now use those numbers to make your fractions. And what will be the denominator of the fractions? Whatever A is. So the denominator will be 4. So we'll have 3 over 4 and 4 over 4. Next step is to reduce. Can we reduce? The first fraction, no, 3/4 is reduced, but the other one we can, so that's 1 over 1. We're doing good. Now make our factors. We didn't have a greatest common factor, so no number in front. Just these. So 4, the bottom becomes your coefficient. So we're going to have 4 right here. And the 3 is your constant, plus 3. And then these two come in to the front and the constant. So our factors are 4x plus 3 and x plus 1. If you FOILed that back out, you would come right back to 4x squared plus 7x plus 3. If you need to pause it, pause it. If not, we'll keep going. All right, this last one, it's a little peculiar because it doesn't have a b term. All right, is there anything common to bring out to the front? No, they don't have anything in common. So we'll just make our x. All right, so this is A, this is C, So what is A times C? We've got 1 times negative 64 is negative 64. And then our B term, it's not there, so we put a 0. So what factors multiply to get negative 64 and add to get 0? Let's see, 1 and 64. Well, one of them has to be negative. So I'll do both. I need more room. Okay, what else? 2 and 32. One of them has to be negative. 4 and 16. One of them has to be negative. Ooh, 8 and negative 8. Hey, do those add to get 0? Yes. So, our little side numbers here are 8 and negative 8. Use those to make your fractions. Our A is 1, so that's our denominator. So we'll have 8 over 1 and negative 8 over 1. Can we reduce those any? Nope. So we go straight into our factors, and we don't have a greatest common factor, so we're going straight in here. So it'll be, this is our coefficient, so we'll have 1x, and then plus 8 from the numerator, and then we'll have 1x minus 8. You can put the 1 in front of the x if you prefer, that's fine. It is still correct. So there's our factors. All right, you see those two multiply to get negative 64, and they add to get 0, which is the B term. That's it for the 5.4 notes. This stuff is really, really important. It's necessary not only in this class, but continuing on in math classes. So let's make sure you get this right. Please come ask questions if you have questions.